Hello everyone. Today we will discuss about the nuclear models. Okay. Nuclear models. Just like your atomic models, atoms looks like how it is said to be existing. Like this, nucleus is also having some models. Just like your atomic models, nucleus is having some models. The first atomic model, it has been given by Bohr and Wheeler. Bohr and Wheeler, they have proposed one nuclear model. That nuclear model name is given as liquid drop model. Liquid drop model. This is the first model. Nuclear model, under that the first model is liquid drop model. It has been proposed by the two scientists. One is Niels Bohr, the other one is Wheeler. Okay. Actually, this is called by the name the Bohr-Wheeler's theory of nuclear fission. Bohr-Wheeler's theory of nuclear fission. Actually, this is called by that particular name. So anyhow, liquid drop model, it has been proposed by Bohr and Wheeler. What it states? The name itself indicating a nucleus is having some similarities with respect to a liquid drop. A liquid drop and a nucleus, they are having some similarities. What are these similarities here now? What are these similarities? Which are those things? So first let us consider some similarities here now. Similarities. So what are the similarities here? So first idea, I will write left hand side liquid drop and I will write right hand side nucleus. Now I suppose to explain the nucleus and liquid drop, they are having some similarities. What are those similarities here now? Liquid drop, all of us already we are aware of in our the previous classes. Okay, maybe in the first degree or maybe in first PU, we have already learnt about so many concepts under the liquid drop. Now let us consider a liquid drop here, which is said to be spherical in shape. Any liquid drop if you are considering which is spherical in shape. This is spherical in shape. Similar to that, a nucleus is also having spherical in shape. A nucleus and a liquid drop, both are said to be spherical in shape. This is the first idea, number one. Second similarity, number two, what it says. If you are considering either water or maybe it is mercury droplet, water droplet, whatever it may be, if it is a smaller one, the droplet, or maybe if it is a bigger one, or still it is a bigger droplet, no problem. As the mass increases here, volume is also increases. So mass divided by volume is called by the name density. Mass divided by volume is called by the name the density. Okay, all of us we are aware of this. So density of each and every water droplet remains constant. Either if you are going for a smaller droplet or a bigger droplet, density remains constant. Similarly, here also in the case of nucleus also I can consider the density, it remains constant. If you are considering hydrogen nucleus or maybe lithium nucleus or helium nucleus or uranium nucleus, either the lighter nuclei or a heavy nucleus. Either you can go for H11 or you can go for even uranium-238-92 nucleus. The density remains same. The density remains same. The density of all the nuclei, almost it is remains same. The density of all the sizes of the water droplet, it is remains same. So density remains same irrespective of the size here. Here also the density of the nucleus remains same irrespective of its the mass number or its atomic number, whatever it may be. Okay. So point number three. Now let us consider here in the case of liquid drop here. In the case of liquid drop here, if I'm considering this is, let us consider this is a water. It is said to be existing here. Water is having so many number of molecules here. These are all the molecules of water. If I'm considering one molecule of water here, it is going to have a force of attraction with the neighboring molecules here now, called by the name the intermolecular forces. The intermolecular forces, it is said to be the short range force. One molecule to another molecule, there is a force of attraction here. This is called by the name the intermolecular forces of attraction. This intermolecular forces of attraction, is a constant forces of attraction. It is always said to be an attractive force. The intermolecular forces of attraction, it is a short range force. This is a short range force here. Similarly, in this case here, in the case of nucleus, if I am considering, the nuclear forces are short range forces. The nuclear forces, you are aware of that one. Inside the nucleus, protons are there, neutrons are there. Between a proton and a neutron, between a neutron and another neutron, between a proton and proton, whatever it may be, there is a force of attraction. Always there is a force of attraction. This force of attraction is also a short range force. It is a short range force. So inside the liquid, molecules are present here. One molecule to another molecule, there is a force of attraction is present, called by the name the intermolecular forces of attraction, which is a short range force. Inside the nucleus, nucleons are there. Protons and neutrons, they are all present here. And each and every nucleon is having a force of attraction with respect to the another one here. That is said to be a short range force, which is existing within the nuclear radius only 10 to the power of minus 15 meter only. That is called by the name the short range force. So this is the third idea, that is. Next one, the fourth idea. What is that? The fourth idea, there is a potential barrier at the surface of the nucleus. Just like in the case of liquid, here there is a potential barrier is present. There is a potential barrier is present here in the case of nucleus. On the surface of a nucleus, there is potential barrier is present. Whereas in the case of a liquid, on the surface of the liquid, there is surface tension is said to be existing. Strictly speaking, due to the surface tension only, the liquid drops are said to be the spherical in shape. Okay, so surface tension is acting on the surface of a liquid droplet. In the case of a nucleus, on the surface of the nucleus, there is a potential barrier is present on the surface of the nucleus. Fifth point, number 5. The fifth point. So let us consider in the case of the nucleus and in the case of liquid, whatever it may be, we are going to give some amount of energy here from outside. From outside, we are giving some amount of energy. For example, if liquid is present here, for this liquid, I am giving some external energy in the form of thermal energy, I can say. Heat energy. If heat energy is given, thermal energy is given to the liquid, it gets evaporated. So it is converted in the form of thermal radiations here now. It is go on converting in the form of thermal radiations. Okay, thermal energy is given. Due to that thermal energy, heat energy, the molecules of the liquid starts to evaporate here from its surface. Here, let us consider there is a nucleus is present here. If you are supplied the energy from outside in the form of maybe a neutron or something like that, a thermal neutron, slow neutron like that, if you are going to supply the energy from outside to this concerned nucleus here, this is going to get emitting some radiations here. Some amount of radiations. This is called by the name the bombardment of a neutron with respect to a nucleus. If it is bombarding with an energetic particle like that of a neutron, nucleus absorbing that energy, and now this particular nucleus is going to get emitting some radiations here. Alpha rays, beta rays, gamma rays, like that. It is go on emitting some radiations. So here a liquid is present. If you are giving a thermal energy, the liquid molecules, it starts to get evaporate. If you are giving an energy to the nucleus in the form of neutron, now the nucleus maybe splits up and it is go on producing some radiations. Okay, this is the fifth point. Sixth point here now, this number 6. There is a binding energy for a nucleus which is a constant. But in the case of liquid here, there is latent heat of vaporization is present. Latent heat of vaporization, you know already about the latent heat of vaporization. If you are taking 1 kg of liquid and go on heating, it is going to get boiled. At that boiling point, without changing its temperature, how much is the energy is required so that 1 kg of liquid is completely converted in the form of vapor is called by the name the latent heat of vaporization. Here in the case of liquid, there is a latent heat of vaporization. Similarly, in the case of nucleus here, there is binding energy is said to be existing. The nucleus, inside that one, protons and neutrons, they are all having an attractive force here. So due to that attractive force, they are not going to get split up easily, and hence I can say the nucleus is said to be stable. That is called by the name the binding energy. How much is the minimum energy is required so that a nucleus can be possible to decompose into its constituent particles is called by the name the binding energy. So this binding energy in the case of nucleus is present. In the case of liquid, latent heat of vaporization is present. Point number 7. The 7th point. When a nucleus undergoes fission, this is the nucleus. It is undergone fission here. Now it is going to get cut down into 2 or smaller pieces here like this, which are also spherical in shape. This one only we are supposed to explain using the liquid drop model, the fission process. This is called by the name the fission process. A heavy nucleus splits up into lighter nuclei. Whether it is a heavy nucleus or lighter nuclei, this is spherical in shape, and the lighter nuclei, they are also said to be under spherical in shape. The same condition is holds good even in the case of liquid. I think probably you might have seen in the case of mercury droplets. If I am taking a mercury bigger droplet, if it is vibrating here and if you are giving an external energy from outside, now it is converted in the form of smaller droplets like this. And each and every smaller droplet is having spherical in shape. The spherical in shape, whatever the liquid drop is present, converted in the form of 2 or 3 number of smaller droplets. Each and every smaller droplet is also said to be the spherical in shape. Now these are all the some of the similarities between liquid drop and the nucleus. Liquid drop and nucleus. Now let me consider some more concept regarding the liquid drop model here. Liquid drop model, especially the liquid drop model. Now let us consider this is a liquid drop. We are giving an extra energy from outside here. We are going to give some amount of extra energy from outside. Now this liquid drop absorbing that energy, and it is converted in the form of, maybe it is said to be a ellipsoidal shape. This ellipsoidal shape, again some amount of vibrational energy, something if it is given here, now it is cut down into almost a dumbbell shape like this, and now it is converted in the form of, or maybe wherever the narrow part is present, it will be cut down into 2 smaller spherical in shape bodies. Based on this idea, we can explain nuclear fission process. And I can say there is an analogy between nuclear fission and liquid drop. Now let us consider this is a neutron here. I will consider this is a neutron. Neutron, if it is accelerated, moving with some particular velocity, having some amount of kinetic energy here, if it is bombarded on a nucleus, maybe this is uranium-235. Now this uranium 23592 atomic number absorbing this N10. Now it is converted in the form of uranium 236 and it is 92 atomic number. So meaning N10 absorbs 23592, it is absorbing this neutron and it is converted in the form of uranium 23692. This is metastable condition is present, this one. It is vibrating. It is having an extra energy. It starts to vibrate here and now it has been occurred in the form of a dumbbell shape. Once it is occurred in the form of a dumbbell shape, then it is converted in the form of a critical state here where positive charges are present here. Now it starts to dislocate and now one is converted in the form of barium 141. The other one is converted in the form of krypton 92 with some number of neutrons also here. Either 2 or 3 number of neutrons is also liberated. So hence nuclear fission can be easily explained by using the liquid drop model. That is the meaning here now. So Bohr and Wheeler, what they did is they have taken the analogy of liquid drop and they have started to explain how the nuclear fission it has been happened here now by using the liquid drop model. Okay, so this is a basic idea here now. These are called by the name the fission fragments. Barium and krypton is called by the name the fission fragments. Target nucleus, projectile this is called by the name the compound nucleus, which is a metastable condition is said to be existing. Now it is converted in the form of barium and krypton with neutrons. Now last concept under liquid drop model is what are the merits of this particular model? What are the merits? We can ask the question even for about 2 marks, 3 marks question also. Write the merits, or I can say what are the advantages of this liquid drop model. Liquid drop model, using that one I can say point number one, the stability of the nucleus can be explained. The nuclear stability can be possible to explain. Point number two, the binding energy of the nucleus of an atom can be possible to explain. The binding energy of I said already what is binding energy. The binding energy of an atomic nucleus can be possible to explain. Number three, the phenomenon of nuclear fission. How the nuclear fission that can be done. Okay, how the nuclear fission it has happened that can be explained by using this liquid drop model. And the phenomenon of radioactivity it has been possible to explain by using this particular liquid drop model. This is number 4. Number 5, I said already in the case of previous one, okay, whenever if you are giving an extra energy here, nucleus, it is absorbing that extra energy in the form of neutron and it is go on emitting some radiations here. So therefore radiation physics, whatever it is coming out as a radioactivity, that can be possible to explain by using liquid drop model here now. So if you are considering any nuclei whose atomic number is represented by Z and whose mass number is represented by A here, Z square divided by A, if it is greater than 52, then it spontaneously undergoes fission. That particular nucleus undergoes fission easily. They are said to be non-stable. They could not be able to have a stability here. Now instantaneously they are going to beget fission. Okay, point number 6, atomic masses and binding energy can be done with a good accuracy by using liquid drop model. So what is that first one? Atomic masses we can calculate and we can determine even the binding energy. With a good accuracy it is possible to mention, it is possible to determine. And we can ask even for about 2 marks question, what are the demerits? What are the demerits of this liquid drop model? The number 1 demerit is, the first demerit is, it could not be able to explain the magic numbers. magic numbers it could not be able to explain. So magic number means I can consider some inside the nucleus proton number and neutron number, whatever it is present here now. That proton number and neutron number, if they are equal to each other, or I can say the total proton number or including the protons and neutrons number, if it is equal to some particular numbers like that of 2, 8, 20, 50, 82, 126, like this. I said two concepts. One is either the proton number is equal to any one of this number, or neutron number is equal to any one of this number, or proton and neutron number together is said to be any one of this number. If it is present, such nuclei is said to be more stable. Such numbers are called by the name the magic numbers, and it could not be able to explain the magic numbers. Number 2, second drawback, second demerit. The spin measurement and the magnetic moment measurement of the nucleus. Of course, I am talking about a nucleus. The nucleus spin angular momentum and magnetic momentum, the two things, magnetic moment, spin moment, could not be able to explain by using this particular liquid drop model. So using the liquid drop model, it is not possible to determine the spin angular momentum and magnetic moment here. Now with a great accuracy, we could not be able to determine so far using the liquid drop model. So and hence this is a failure model. Liquid drop model is a failure model. Next model is shell model. Shell model, it can explain the magic numbers easily. Okay, it can explain the magic numbers. Why these particular magic numbers, if a nucleus is containing, they are said to be more stable. It can be explained by making use of shell model. But liquid drop model could not be able to explain the magic numbers, and it could not be able to explain the spin momentum and magnetic momentum, the detection and measurement that could not be able to happen in the case of liquid drop model here.